These theorems can look a little bit complicated on paper, but they're really not that bad. This first question says, determine whether Rolle's theorem can be applied to the function on this closed interval, and then if it can be applied, find all the values of c in the open interval such that f prime of c is equal to 0. Here's what it's saying. If I have a function that starts at some point, and it comes back to that same y value, somewhere there must have been a spot where the slope was equal to 0. That could have happened a lot of different times. So if I start here and I come back here, maybe I did this. There's at least one place. In this case, there are two. There are two places where that slope became 0. And so the first thing we have to do to figure out if Rolle's theorem applies is we've got to know, does my function start at one spot and come back to the same y value in my interval? So what I need to do is I need to check my endpoints here and see if I'm at the same y value. Otherwise, Rolle's theorem doesn't apply. So all I got to do is I got to check f of 2 and f of 4, and I have to see what y value I get. So if I plug this in, I'm going to get 2 minus 2, which, oh, by the way, is 0, so it doesn't matter what all this is, it's going to be 0. If I plug in 4, I've got 4 minus 2 times 4 minus 3 times 4 minus 4. Oh, look, that's 0, so it doesn't really matter what all this is. I'm going to get 0. It's a complete coincidence that these are both zeros. It could have been any number as long as they match, then Rolle's theorem applies. It doesn't have to be 0. It can be any y value, but as long as these two values match, then Rolle's theorem can be applied. So that first part is done. We've checked that. So if Rolle's theorem can be applied, find all the values of c. That's just asking for the x values. It's asking what x values in the open interval, so I'm not checking the endpoints, such that the derivative is equal to 0. So I've got to find the derivative of this function, set it equal to 0, and solve for x. That's all there is to it. I do need to check and make sure that whatever x values I get fall within that interval that I care about. So to take the derivative of this function, I've got some options. I could do a giant product rule where I said this was my first and this is my second, but then within my first, I've got a first and a second. We could do that and it would be a good exercise, but let's simplify it and then take the derivative. Let's FOIL out this first one. So f of x is equal to, I'll have x squared minus 2x minus 3x. So outer and inner gives me minus 5x, and then my last gives me plus 6 times x minus 4. Let's start here and take the derivative. That looks much better. Still got a product rule though. I've got a first and a second. So f prime of x is equal to the first times the derivative of the second, which is just 1, minus the second times the derivative of the first, first times derivative of the second plus the second times the derivative of the first. And if I'm going to set this equal to 0, I would really like to get this down to a quadratic that I could solve, some method for quadratics. So let's see. I'll keep this as it is. And then I'm going to factor this out, FOIL this out. So x times 2x will give me 2x squared. Outer gives me minus 5x. Inner gives me minus 8x. And then last gives me 20. And if I combine my like terms, I'll get 3x squared. Make sure I get everybody. I got x squared and 2x squared. And then for my x terms, I have minus 5x, minus 5x, minus 8x, so that's my minus 18x. And then plus 6 plus 20 gives me plus 26. Is that everybody? Should be good. Now what I need to do is I need to set that equal to 0 and solve for x, and only choose the x values I get that are within my window of 2 to 4. This looks gross. Let's go ahead and do classic quadratic formula on this. Quadratic formula, sing your Pop Goes the Weasel song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Nobody said it was going to be pretty. So 18 plus or minus the square root of, okay, on my scratch paper over here I did 18 times 18, you'll get 324. 12 times 26 over here on my scratch paper I've got is 312 over 16. So, sorry, just a 6. 2 times 3 is 6. Okay, so I've got 18 plus or minus the square root of 12 over 6, which is, let's see, 18 over 6 plus or minus 12. That's, let's see, that's 2 times 2 times 3, so I can pull a 2 out. So that's 2 square roots of 3 over 6. So if I simplify that, 18 over 6 is 3 plus or minus. I can simplify that to be 1/3. So plus or minus the square root of 3 over 3. Now, these are my x values, and I need to make sure that they fall in my window. My window was from 2 to 4. The square root of 3 is going to be between the square root of 1 and the square root of 4, so it's going to be somewhere between 1 and 2, right? So we'll say maybe that's 1.5-ish divided by 3, so this is going to be a fraction that's less than 1. 3 plus a number that's less than 1 is going to be less than 4, and then 3 minus a number that's less than 1 is going to be greater than 2, so both of these values fall within my range, right? I know this is tedious, but I'm walking through these things to show you how I would think through things without using a calculator. I don't have to know what that exact decimal is to make a judgment call over whether or not that's a good answer, right? I want you to be developing that intuition without having a calculator to double check yourself all the time. So let's go back, look at the original question. It said determine whether Rolle's theorem can be applied. We did that. And then if the theorem can be applied, find all the values of c in the open interval such that the derivative is equal to 0. We found our derivative, we set it equal to 0, we did a quadratic formula, and we got a final answer. X, or c, can be 3 plus or minus the square root of 3 over 3. So Rolle's theorem is when your y values for your endpoints are the same. Doesn't matter what happens in between as long as your endpoints are the same y value. Let's look at the next question now about the mean value theorem. Rolle's theorem is a specific case for the mean value theorem. Let's look at what it says. Determine whether the mean value theorem can be applied to the function on the closed interval. If the mean value theorem can be applied, find all values of c in the open interval such that f prime of c is equal to f of b minus f of a over b minus a. That's a whole lot of words. Let's look at what we're actually finding here. My function is x squared. Nice easy sketch there. And my interval is from -1 to 2. So at -1, let's say I'm here, and at 2, we'll say, I know that doesn't line up, but we'll say I'm up here. This is the secant line that I can draw between my 2 points. If this had been Rolle's theorem, my other point would have been up here, and I would have drawn a horizontal line between them, right? But mean value theorem can apply to anything. My 2 endpoints don't have to be at the same y value. What I'm looking for now It says, if the mean value theorem can be applied, find all the values of c in the open interval such that the derivative is the same as the slope of the secant line. All of this is just asking for the slope of the secant line. I'm doing f of b minus f of a over b minus a. That's rise over run. Do you see it? That's your change in y over your change in x. It's just the slope of that line. And so I'm asking, where is the derivative the same as the slope of the secant line? And so I'm asking, where on here could I draw a line parallel to this? And I'm thinking my answer is going to be somewhere in here. If I followed the secant line around on this graph, when would I get one that was parallel to the secant line? Right? If I drew tangent lines all along this, when would I get one that's parallel to the secant line? So I think it's going to be somewhere in here, but we want to do this with the actual math, right? So the first thing, let's find the slope of the secant line. Let's find f of 2 minus f of negative 1 over 2 minus negative 1. If I do 2 squared, I'll get 4. If I do negative 1 squared, I'll get 1. And then uh, 2 minus negative 1 gives me 3. So this looks like 3 over 3. I'm looking for where is the slope equal to 1. Now what I need to do is I want to find the derivative of this function, and I'm going to set that derivative not equal to 0. I'm not doing Rolle's theorem. I'm going to set the derivative equal to 1 and see what x values I get. So taking the derivative, f prime of x is equal to 2x. I want to set 2x equal to the slope of my secant line, which was 1. And so x is equal to 1/2. And that's actually not too bad from what we predicted just from our simple little sketch.